Hello everyone. So, now we're going to dive a little bit further into the special properties of isosceles triangles. So, as we covered in the first problem, we have that the two congruent sides of an isosceles triangle are called the legs. In this case, AB is a leg and BC is a leg. The angle where the legs intersect is called the vertex angle. So in this case, that would be the angle B or the angle 1. The side opposite to the vertex is called the base, that being AC in this case. And the angles along the base are called the base angles. That's angle 2 and 3 or angle A and C. So, the isosceles triangle theorem states that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. What does it mean by angles opposite to those sides? Well, the way I always think about it is if I were to draw a line through an angle, let's say angle A, and we notice that that line going through the middle of that angle A crosses the side BC, which is one of our congruent sides. That means that angle A is opposite to BC. Now, if I draw an angle through a line through C, it crosses through the side AB. That means the angle at C is opposite to the side AB. And if I draw a line through the angle at B, it hits the side AC, so the angle B is opposite to AC. So, if two sides of a triangle are congruent, the angles opposite to those sides are congruent. Well, let's look at the two congruent sides, AB and BC. If I draw a line through angle A, that means it's opposite to BC. So one of the congruent angles is angle A. And the other one that is going to intersect through AB, the other congruent side, goes through the angle C. So those are the two opposite angles to the congruent sides. So by this theorem, I know that angle A is equal to angle C. Written out mathematically, that looks something like this. If AB is equal to BC, then angle A is congruent to angle C. I should really put the congruent symbol here as well. So if AB is congruent to BC, then angle A is congruent to angle C. The converse of this theorem, the reverse direction of this theorem, states that if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So this is just the reversal of the first theorem. If angle A is congruent to angle C, then AB is congruent to BC. So the basic gist of it is that in an isosceles triangle, two equal sides imply two equal angles, or that we have that two equal angles imply two equal sides. So let's see what that actually looks like in a problem. In the first three, we have that we want to find each missing measure. So for instance, let's start by finding angle J. Well, I notice we have two congruent sides, JK and LK. Two equal sides mean two equal angles. And in this case, well, the side opposite to KL would be the angle at J. That means J and L must have the same measure, that being 68 degrees. So, how do we find angle K? Well, we know that the two angles are 68 degrees. And we know that the sum of the three angles in a triangle add up to 180 degrees. So I'm going to say that 180 is equal to 68 plus 68 plus angle K. And then we can just simplify this equation and solve for angle K. So 68 and 68 is 136. Subtract 136 on both sides, and we get that angle K is 180 minus 136, or simply equal to 44 degrees. And in the next video, we will cover the rest of these sets of problems.